Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 23, Production Planning, how to avoid chaos and delays. When the schedule breaks, the whole factory breaks. In this episode, we explore how modern tools, real-time data, and AI help planners build accurate, flexible, and realistic production plans, even when things change fast. You'll hear how DBR77 supports smart scheduling, real-time adjustments, and integration across systems, turning your production plan into a living, data-driven map. Because good planning isn't about guessing, it's about knowing. Factory on Air is powered by DBR77, the platform that helps you plan with confidence, adapt instantly, and deliver on time. Every time. Let's get started.
Welcome back to the Deep Dive. Today we are pulling back the curtain on what you could call the central nervous system of every manufacturer, the high-stakes, high-stress world of production planning. And, for anyone who might think this sounds a little dry, maybe a bit administrative, I really want you to reconsider.
Right.
This isn't just about making a schedule. It's a difference between profit and penalties, between customer loyalty and just complete operational disaster.
It truly is. Production planning is the absolute heart of every single plant, every factory, every operation that makes physical things.
Your engine room.
Exactly. And if that heart falters, if the schedule fails, the economic impact is immediate. It's severe.
So what does that look like? What happens?
Well, you face machines just standing idle, waiting for parts. You've got highly skilled staff just waiting around for instructions. And critically, you get those client calls demanding to know where their shipment is.
The angry phone calls.
The angriest. It's the ultimate chaos trap. And really, keeping your credibility in a competitive market all hinges on escaping it.
And that's pretty much our mission for today. We are taking a deep dive, looking at the core challenges that just plague modern industrial scheduling. We're going to identify the precise data points that separate success from failure and explore how advanced tech can transform planning from, this reactive chore it is for most companies into a truly predictive, real-time optimized process.
And we really want to arm you, the listener, with a structured approach to this. We want to pull out the crucial insights on how to plan better, faster, and more securely using, data science and smart integrated tools.
Okay.
Like this is really the path from constantly putting out fires to strategic, predictable production.
Okay, let's unpack this. Let's start at the beginning, right? Understanding the anatomy of chaos. Where does it all go wrong?
When we look at the places where schedules consistently fail, the sources, they really point to four big, pervasive problems. The kind of problems that pretty much guarantee the planning team is just spending their entire day in crisis mode.
And the first one, which you could argue is the root of all the others, is what the sources call data lag and deficiency.
Yes.
It's the simple fact that you're making a plan based on information that is already stale.
And this isn't just, a minor inconvenience. It's a guarantee of failure. The main bottleneck is the lack of current real-time data.
On what specifically?
On everything. Machine availability, material stock, even just who was on the floor. Imagine a planner sitting down on Monday morning to schedule the week.
Right.
And they're using inventory reports that were finalized Friday at 5 p.m.
So much could have happened over the weekend. Maybe an unexpected maintenance job came up, or a critical component was moved to a staging area, but it hasn't been, logged in the system as used.
Exactly. The planner assumes it's all available, but reality is already hours, maybe even days, ahead of the plan they're building.
So the schedule is built on
what?
Assumptions, outdated information.
Pretty much. By the time that schedule is sent to the shop floor, let's say 8 a.m., it is already obsolete. A key machine, which the plan says is available, might have had a minor fault at 7.45.
Or a specialized operator called in sick 15 minutes before their shift.
And if the system doesn't immediately reflect that change, the planner has scheduled resources that simply aren't there. That creates instant bottlenecks and delays right down the line.
And that inability to handle change, I guess it leads directly into the second huge problem, the failure of manual scheduling. We're talking about spreadsheets, right? Whiteboards, these isolated systems trying to keep up with an environment that's just constantly in flux.
Manual scheduling is, it's just fundamentally flawed once the complexity of production goes beyond a few simple variables.
There's a limit to what a person can juggle.
A very real limit. A human planner, no matter how brilliant they are, can only keep track of so many things at once. Machine capacity, tooling, material arrivals, operator shifts, different customer priorities.
And when you have hundreds of work orders and dozens of constraints.
The human brain is just overwhelmed. The speed of what's happening on the shop floor moves exponentially faster than a person's ability to process it all and react.
So if one unplanned thing happens, and in a busy factory, that's probably happening dozens of times a day.
Dozens of times a shift, even.
Right. Then that beautifully crafted manual schedule is instantly irrelevant. It stops being a guide and just becomes, what, a historical...
An historical artifact, yeah.
Yeah.
And critically, the time it takes for a human to manually fix it, to collect the new data, calculate the ripple effects, reschedule everything that depends on it, that is all time lost to production.
And by the time they finish the update...
Another thing has probably happened, making the new schedule obsolete too. It's just this endless treadmill of reactive work.
Which brings us to the third problem, which is more of a mindset issue. The reactive versus predictive mindset.
Yes, the default mode.
Traditional planning forces companies into this state of perpetual crisis management. They're always reacting to problems, never getting ahead of them.
Always firefighting.
Yeah.
When a machine breaks down or material is late, the planning team, and usually management too, rushes into emergency mode.
Right.
They stop what they're doing and spend all this time asking, who needs this resource? How does this affect our deadlines? Is there another way?
Yeah.
It is incredibly stressful, incredibly costly, and you lose so much institutional knowledge in the process.
That's a key point that I think often gets missed. The opportunity cost.
Absolutely.
The cost isn't just the stress or the wasted hours. It's that the planner never gets a chance to actually optimize. They can't look ahead strategically or refine processes because they're always just trying to survive the day.
Exactly. If you're not using historical data and real-time inputs to predict potential problems, like knowing, that machine Z is statistically likely to need maintenance soon based on its cycle count, then you are always operating from a position of weakness.
The cost and the stress, they don't just eat away at profit. They basically choke off any chance for continuous improvement. The goal just becomes survival.
It shifts from efficiency to just getting through the day.
And finally, there's the structural problem, the planning reality disconnect. This is about the poor integration between the plan itself, which might be created in its own little silo.
Right, in a separate system.
In the actual physical realities and constraints on the production floor.
When a schedule is made in isolation, without that strong two-way feedback from an MES or from IoT sensors, it just ignores critical details. For instance, the plan might look perfect. It says, start job A at 10 a.m. right after job Z.
Looks great on the screen.
Looks beautiful. But the planner, who's only working with high-level data, might not have accounted for the mandatory 60-minute cooling period that the specialized tool needs after job Z.
Or in, say, food production, the mandatory 30-minute cleaning and sterilization that has to happen before job A can even begin.
That weak integration means the optimized schedule on the planner's screen is, frankly, impossible to execute in the real world.
Which must be so frustrating for the people on the floor.
It leads to massive frustration, poor compliance, because the operators know the plan is wrong and they have to invent their own workarounds, and ultimately miss deadlines based on schedules that were never achievable to begin with.
So we've established that the chaos is really rooted in bad data. Outdated, siloed, just wrong data. The path forward, then, isn't just to collect more data, right? It's about getting the right data.
Yes, it's about identifying and properly integrating the exact data points you need to build a successful, resilient schedule. This is the move from just, recording things to actually using a structured, high-definition data stack.
It's about having the right information right now.
Exactly.
Okay, so let's break down the components of this essential fuel. Where do we start? The non-negotiable foundation seems to be real-time resource status. What does that actually cover beyond just, is the machine running?
Oh, it has to be much more granular than that. You have to know the machine load and availability in real time. Is it running productively? Is it idle? Is it reserved for an upcoming setup? Is it flagged for maintenance?
And the MES, the manufacturing execution system, is where that truth lives?
That's your source of truth. And then you have to connect that machine status to the materials it needs. So that means having real-time inventory levels.
Not what the ERP system thinks we bought 2 weeks ago.
No. It's what the warehouse management system, the WMS, confirms is physically sitting in bin 4B on the floor, ready to be picked for the next job.
Crucial distinction.
Absolutely crucial. We also need precise data on the status of all the work orders that are currently in progress. Are they 50% done? 90%? Has a quality check flagged them for rework? This is active, live execution data.
And what about priorities?
That's the other piece. Clear, unambiguous priority levels for customer orders. If two big jobs are competing for the same machine, the system has to know instantly which customer's deadline has the bigger contractual penalty or strategic value.
Okay, so moving beyond the raw materials and machines, the sources really emphasize operational constraints and human factors. These are the variables that the old static planning systems almost always miss.
And it's why those plans fall apart so quickly. I mean, think about something like changeovers or setups. The time it takes to switch from making widget X to gadget Y is super dynamic.
It's not always the same.
Never. It depends on the sequence. Switching from X, which uses red material, to Y, which uses blue, might take 2 hours of cleaning. But switching from X to Z, another red material, might only take 15 minutes.
So the system has to be smart enough to sequence jobs in a way that minimizes all that cumulative setup time instead of just using some fixed average.
It has to calculate the setup time dynamically based on the job that just finished and the one that's about to start. It's a variable, not a constant.
And what about the human element?
That adds another layer of dynamic complexity. It's not enough to know that you have, say, 20 people scheduled for a shift.
Yeah.
You need to know the specific availability of skilled operators for specialized jobs.
Right. So if a critical CNC machine needs an operator with a level 5 certification.
And that operator is only available from 11 a.m. to 3 p.m. because they have training later. The schedule has to be built around that reality. It's a hard constraint. If you ignore that, you're just planning for a bottleneck.
This all leads to what seems like the most powerful data input. Leveraging historical insight. You call it the predictor.
Because it is. If the data stack is the fuel, historical insight is really the engine of efficiency.
So historical data isn't just for accounting.
Not at all. It's the predictive power that turns planning assumptions from, subjective guesses into something like actuarial reality. We so often see planners building padding into their schedules.
Adding 10% just in case.
Exactly.
Yeah.
Because they don't trust the underlying data.
So what specific historical data points get rid of that need for padding?
You need detailed historical cycle times. Not what the official standard says a job should take, but how long did job X actually take the last 20 times you ran it?
Mm-hmm.
You need equipment failure rates, mean time between failures, which machines historically break down more often. And you need past delivery lead times. How long does it really take from when a job is finished to when it's on the truck?
So if the standard estimate for job A is 1 hour, but the historical data consistently shows that 90% of the time it actually takes 75 minutes because of, material handling issues.
Right, or required quality checks.
Then scheduling it for 1 hour means your plan is already 15 minutes behind before the job even starts.
You're basing the plan on a lie, like you said before. By using this granular, high-volume historical insight, the planning system can stop relying on these subjective, idealized estimates.
It can use what actually happens.
It calculates achievable planning assumptions based on real-world execution data. And that is how predictability is born. It allows these complex systems to schedule not just efficiently, but realistically.
So we've identified the chaos, and we've gathered this massive real-time historical data stack that's needed to fuel the whole process. But frankly, no human mind can possibly process all those dynamic variables and spit out an optimal schedule instantly. And this is where the tech, has to do the heavy lifting. Let's explore how artificial intelligence really elevates planning beyond human capacity.
This is the fundamental shift.
Yeah.
The sheer volume and variability of the data, it just necessitates automated intelligent processing. And the first, most obvious benefit is what we can call AI's simulation advantage. Think about a human planner trying to map out the best schedule for a week. They might, try to manually move a few variables around, maybe test 3 or 4 different paths over the course of an afternoon.
But the speed difference is just astronomical.
Completely. The AI doesn't just look at a few paths. It generates and analyzes hundreds of thousands, sometimes millions, of possible schedules to rigorously find the absolute optimum path.
It's not just a linear improvement.
It's an exponential leap in combinatorial analysis. It does in minutes what a whole team of humans couldn't do in a year.
And that speed is what unlocks genuine multi-factor optimization.
Exactly. The AI isn't just focused on one single goal, like maximizing how much a machine is used and then ignoring everything else.
Right.
It simultaneously weighs every single competing constraint. Resource availability, dynamic changeover sequences, customer priorities, hard deadlines, even things like energy costs and product rotation complexity, all in the same analysis.
And that balancing act is really the core challenge that manual planning just fails at. A human planner might realize that batching all the similar jobs together minimizes change over time, which saves money. But doing that might push a high-priority customer's order past its deadline, which costs credibility and brings on penalties.
An advanced AI system assesses that exact trade-off instantly. It finds what's called the Pareto-efficient solution, the schedule that's optimal across all objectives, even if it doesn't max out any single metric.
There it finds the sweet spot.
It finds the sweet spot. It weighs the financial cost of a penalty against the efficiency savings from batching. It's about finding the path that satisfies the most important things without completely sacrificing the others.
Now, what takes this from just being fast to being truly predictive is the capability to simulate risk. The sources highlight that systems using AI can go beyond just generating the best schedule for right now.
Yes, they can actively engage in simulating risk and proposing scenarios.
Which is a total game changer.
It really is. The AI can look days or even weeks into the future, predict the probability of a delay happening. Maybe it models a bottleneck forming at Station 4 because of a peak load coming up on Tuesday, and it can automatically propose alternative corrective scenarios before the problem even exists in the real world.
So if we look at systems that really showcase this kind of intelligence, like the platform approach used by DBR77, for example, the goal isn't just to schedule, it's to test scenarios.
Right.
The planner can actually ask the system, hey, if I move this high priority job forward, what is the exact ripple effect across my entire facility? And the system gives an answer in seconds.
Yes, exactly. DBR77, which we can cite as a good example of an integrated platform, demonstrates this perfectly. It changes the conversation from here's a rigid schedule to something more like
A dialogue.
a dialogue. Here's the optimum plan. And by the way, if machine B goes down for 4 hours, here are the 3 best alternative paths to reroute production. And here's how each option affects your top 5 customer deadlines.
What?
That level of foresight and immediate solution generation is just impossible without AI and real-time data integration.
Which brings us to a really practical question. When automation becomes essential, when does manual planning just stop being a viable option?
The material really defines 3 key scenarios where it's pretty clear.
Okay.
First, when production is complex, highly dynamic, and depends on tons of variables. If your factory has a huge variety of products, complex routings with hundreds of possible paths, or needs frequent resequencing, manual planning just can't handle the complexity.
It breaks.
It breaks. Second, when you have frequent, high-impact, unexpected events. If your market demands extreme agility, you get urgent customer orders every day, or machine failures are common, the manual scheduler is just reduced to being a human data entry clerk.
Spending 90% of their day just reacting and updating.
All day. And third, when your people's time is just too limited for comprehensive manual planning, automation frees up the planner's time so they can shift their focus from tedious data entry and manual math to strategic review, analyzing scenarios, and higher-level process optimization.
So the critical takeaway here is this. Automated planning, like what you see in these integrated platforms, is really intelligent support for the planner.
Yes, that's the key.
It's not about getting rid of the human. It's about giving the human supernatural processing power so they can focus on making high-value strategic decisions.
Precisely.
Now, we have to confront the messy reality of manufacturing. Because even the best plan, generated by the fastest AI with the purest data, is going to run into turbulence.
Unavoidably.
A supplier's truck gets stuck in traffic, a machine has a freak accident that no model could predict, or sales closes a massive urgent order that has to jump the queue.
And this is the moment of truth. This is where a system's dynamic resilience is tested, and it's the measure of its true worth. It's the need for instant correction.
You need a tool that can handle those common surprises. The machine breakdown, the sudden material shortage, without the planning team having to spend a whole day manually rebuilding the entire schedule from scratch.
In a traditional fragmented setup, one machine going down can cascade into hours of work for the planner. They have to play detective, manually figuring out which jobs are affected, where the new bottlenecks will be.
What material needs to be reordered or rerouted? It's a nightmare.
The ripple effect can be absolutely devastating. But advanced systems have a real-time response mechanism because they are constantly listening.
They're integrated.
They're integrated with the MES, IoT sensors, logistics trackers. The second a critical input changes, a machine's status flips from running to fault, or a material delivery is logged as 3 hours delayed. The system instantly absorbs that new data.
And that real-time data flow triggers an automatic recalculation.
That's the magic. The AI engine doesn't wait for the planner to type in the change. It instantly runs a dynamic simulation of the new reality and updates every single dependent schedule.
And this is where the planner's job completely changes.
The workload shifts entirely. The planner is no longer the detective or the calculator. They don't spend hours trying to figure out what happened. They get an immediate alert that shows the exact impact.
Like what? What would it say?
Something like, warning, machine B down. Customer Z's order delivery risk increased by 80%. Estimated delay now 3.5 hours.
And crucially, the system doesn't just deliver the bad news.
No, it presents a set of pre-calculated, optimized options for how to fix it.
So it's solution-oriented.
Exactly. The system might propose, for example, Option 1, reroute the job to the available machine C, which costs 10% more, but saves the deadline. Option 2, prioritize a different job that can run on the down machine's twin later today. Or, Option 3, accept the delay, notify the customer, and move other lower priority jobs forward to keep utilization up.
So the planner immediately moves to evaluating these pre-calculated options and picking the best path.
And they can minimize the ripple effects across the whole facility in minutes, not hours.
We've talked a lot about data and systems, but you made the point that planning doesn't exist in a vacuum. Its real strength comes from seamless, frictionless integration with every other major business system in the facility.
This is the idea of connecting the digital dots. A modern planning tool can't just be a standalone module. It needs deep, robust, two-way integration with the major enterprise systems that handle the financial, material, and operational data.
So we're talking specifically about the big core systems, the ERP enterprise resource planning, that's where the customer order lands and the financials live.
Right.
The MES manufacturing execution system, which is the direct link to the shop floor, tracking what's actually happening, and the WMS, the warehouse management system, which manages the physical inventory.
And it's worth detailing the critical handshakes between them. When a new customer order goes into the ERP, the planning system has to instantly pull the bill of materials, the capacity needed, the delivery deadline. That has to be automatic.
And the other way.
And when a machine finishes a job, the MES reports the actual exact cycle time and execution details back to the planning system for dynamic adjustments and also back to the ERP for real-time cost analysis.
So that integration makes sure the schedule is always based on facts streaming directly from the shop floor, not assumptions from some siloed spreadsheet.
If the systems aren't talking, you're just introducing massive risk. Inefficiency from manual data entry, which guarantees errors and lag, and a total lack of credibility, because the plan is only as good as the last manual data import.
The plan has to reflect the single source of truth that these integrated systems represent.
It has to.
The sources refer to this as the platform approach to planning, using integrated systems like DBR77 as an example to show the value. This isn't just a piece of software. It's a unified ecosystem that actually understands the specific process flows of the plant.
And a single integrated platform gives you centralized control and total visibility. The planner isn't jumping between 5 different screens trying to reconcile different data sets.
And inside this unified environment, what can they do?
Well, they can use the AI engine to build the initial schedule, knowing it's based on that single source of truth from the integrated ERP, MES, and WMS.
And they can watch, I assume, how that plan reacts in real time to new data.
They can see it on a high-definition visualization. They can see the impact of a new quality hold or a maintenance window projected onto the future schedule instantly.
And for strategy, what's the big advantage?
For strategy, they can test future load scenarios and run what-if simulations without disrupting real production. If the sales team thinks demand for a product will jump 30% next quarter, the planner can simulate that load against current constraints in the platform and immediately see where they'll need to invest, maybe in new tooling or hiring more skilled operators to meet that future demand.
So having all that complexity managed in one integrated place, tailored to the plant's needs, is what elevates planning.
It elevates it from a fragmented, reactive chore to a holistic, strategic function that actually guides the entire business.
We've covered the whole technological transformation needed for this kind of intelligent planning, but let's bring it home. What does this level of sophisticated, data-driven, AI-optimized planning actually translate to when it hits the balance sheet? And maybe more importantly, how does it affect customer trust?
The benefits are immediate and they are very measurable.
Yeah.
Starting with the big ones. Financial and credibility gains.
Okay.
Better planning directly leads to way fewer production delays and schedule conflicts, which drastically reduces the risk of those costly contractual penalties you find in so many vendor agreements.
And when a manufacturer consistently hits its delivery dates, something invaluable happens.
Something priceless. The schedules they provide are seen as achievable, which increases reliability and transparency across the whole supply chain. That market credibility, you can't buy it.
If a critical supplier tells you an order will be there on Thursday and it always arrives on Thursday, that creates immense trust.
Exactly. The shift from, I hope the plan works, to, I know this plan is optimal and achievable is the greatest asset you can possibly gain.
So let's move from the theory to the concrete impact. The sources have some really good concrete examples of implementation success, the aha moments.
They really are.
Let's start with example 1 from the metal industry. This one highlights a massive efficiency gain in just the time spent planning. A firm was able to shorten its planning time from, 8 hours a day?
8 hours of manual work.
Down to just 15 minutes.
8 hours of a highly skilled, highly paid planner's time just trying to reconcile conflicting data in spreadsheets, down to 15 minutes of AI-informed review and confirmation. That is an exponential saving in personnel cost.
And it changes the job itself.
It transforms the job. The planner is now focused on strategic, high-value optimization, not tedious, error-prone data entry.
Okay, example 2 focuses on a high-agility environment, food production. Here, the main benefit wasn't just saving time internally, it was about market responsiveness.
Yes. The facility gained the real-time ability to react instantly to changing orders from big, demanding retail chains.
And in food production, that's everything. Shelf life, consumer trends.
You have to be instantly agile. If a major supermarket suddenly increases an order or changes the packaging mix at short notice, which happens all the time, a manual system would be paralyzed.
Right.
But this data-driven platform allowed the factory to instantly assess their capacity and reroute jobs to meet that demand without messing up all their other existing orders. Agility there translates directly into market share.
And it avoids spoilage costs.
Big time.
And finally, example 3. A producer of precision devices. This shows the direct impact on core performance metrics. They cut the number of delivery delays by 40%.
Just think about that number. A 40% reduction in delivery delays solely due to implementing planning based on real-time data and AI.
The implications of that are huge.
Huge. Less working capital tied up, fewer angry customer calls, no more penalty payments, and much more predictable revenue. It just proves the whole premise. When you base your plan on high-definition facts and optimize it with AI, the schedule becomes real, achievable, and reliable.
So to synthesize this entire deep dive, we've really mapped out the necessary journey for modern manufacturing. It requires this fundamental shift away from
Reactive, data-starved chaos.
Yeah.
Where planners are constantly firefighting based on old assumptions.
To a proactive, optimized scheduling system that's driven by real-time intelligence and the processing speed of AI.
And the core transformation isn't just about faster calculations. It's about holistically integrating the entire operational landscape, the ERP, MES, WSS, so that the schedule is always a true, verifiable reflection of the physical reality on the shop floor.
And by using that granular historical data for predictive assumptions and using AI to simulate hundreds of variants, we go from just crossing our fingers and hoping a plan works
to knowing it's the optimal, most achievable path forward.
This systemic change transforms the planner's role from a human calculator buried in data entry to a strategic decision maker.
They're supported by a system that instantly manages turbulence, minimizes those costly ripple effects, and provides measurable, quantifiable gains in time, agility, and most importantly, customer reliability.
So here's a final provocative thought for you to mull over as we finish this deep dive. If advanced technology and AI can optimize a production schedule, balancing hundreds of variables and competing financial priorities in just minutes, what other complex industrial processes are currently being critically bottlenecked by manual, siloed decision-making?
That's a great question.
Where else in your organization are you still relying on subjective assumption and human padding instead of data-driven integrated fact? And how quickly could adopting this kind of approach transform that weak link?
Thank you for joining us on the Deep Dive.
We'll catch you next time.